Hey, Plumber Tom here. If you're studying from the Mathematics for Plumbers and Pipefitters book, you've come to the right place. I'm glad to help you with your understanding. Don't forget to check in the description below this video for access to books and resources that will help you with your understanding. There are online courses and other things that you can take that will help you prepare for a state test. When you purchase from those links, you're helping me to be able to create more great content. Thanks for watching. Hello and welcome to this presentation of Mathematics for Plumbers and Pipefitters. I am Thomas Hicken, and today we will be looking at Unit 1, which is a review of some of the basic fundamentals. In this unit specifically, we look at some basic rules for mathematics. And in this unit, they point out that this book is building on math skills that you probably or should already have. And because of that, they're going to make some assumptions about what you already know. So as we get into some of this, if there are areas that are unfamiliar or that you'll feel weak in some of these fundamentals, now is your time to brush up, to ask the questions, to prepare yourself. Because as we go forward, it's just going to get more difficult if you don't have a solid understanding of the fundamentals. Some of the other specific things that they assume you already know are that you will have the ability to do basic mathematical operations. We're talking about addition, subtraction, multiplication, division, as well as positive and negative integers, fractions, percentages, and decimal fractions. So again, all that stuff you probably had in middle school, high school, you've seen it before. Hopefully you're comfortable with that. Also, they assume that you have basic experience with substituting values. This is where we get into some of the pre-algebra or equations where we're using letters to represent a value. We do that a lot in the formulas that apply to plumbing. They assume that you have a familiarity with measurements of length, angle, weight, and volume. And we go over those all quite a bit. But when we're talking about measurements, that's just the basics of understanding a measuring tape or how we measure linear distances, as well as angles. We're going to solve problems for volumes of containers. They assume that you have the ability to visualize drawings and sketches and to extract information from charts and graphs, and that you can read numbers on a number line. So again, the encouragement at the beginning of this in the introduction is that if you don't understand, now's the time to get help. And that's fine. It's okay. Do not be discouraged if math is an area that you need to work on. Let's work on it. You can do this. Hopefully by now you're familiar with the fact that there are two systems of measurement in the world. Unfortunately, we in the United States of America are stuck with the old English version, and they're calling it the English style of measurement here in the book, with feet and fractions of an inch and yards and all these random ways of measuring things. On the other hand, there's the metric system. You know, I grew up in the school system in the 1980s, and they talked about someday you guys will be using the metric system. And so they'd teach us the metric system. Well, come on. The metric system is so extremely simple. It's all powers of 10, right? And yet, in spite of how easy and fantastic it would be, the cost of transitioning over has been so much that no one's doing it. We haven't done it yet. You know, and it's been a long time since I was in grade school, and we're still stuck on this English measurement. And I'm sorry for your sake that that's where we are at, but that's where we are at. So a lot of what we'll study in this book is going to be based on those measurements of feet and inches and fractions of an inch, and converting those to fractions and decimals so that you can get along and get around in the current construction world. All right, let's have a look at linear measurement. We're going to start really simple. So here we go. How many inches are in a foot? Do you remember? There are 12 inches in 1 foot. Great. How many square inches are in 1 square foot? So we were looking at linear. Now we're looking at an area. That means length times width, and we get a square inch area. How many square inches are in 1 square foot? Well, if we just line that out in an equation form, look at this. 1 square foot is 1 foot times 1 foot. If we convert those into inches, then for each of those feet, there are 12 inches, and we would say 12 inches times 12 inches is the same area as 1 foot times 1 foot. Following so far? Good. We finish that 12 times 12, and we end up with 1 square foot is equal to 144 square inches. It looks something like this. You can see it on the left and on the top. 1 foot by 1 foot is also the same as 12 inches by 12 inches. Now, here's a mistake that plumbers make quite often, especially when we're doing math in this class. We do this. Say you're given a problem that says convert 20 square feet into square inches. Well, we think, okay, there are 12 inches in a foot, so what I'm going to do is take my 20 square feet, times it by 12 to convert it to inches, and I get 240 square inches. Well, that's not true, because as we just looked at, there are 144 square inches in 1 square foot. Our equation really needs to be 20 square feet times 144 equals 2,880 square inches. May I please point out that 2,880 square inches is much more than 240 square inches. I mean, we're talking about more than 10 times the difference. So this is a mistake that's commonly made as we're in a hurry to convert things from square feet to square inches, like, okay, times it by 12 and move on. But slow down, pay attention to what you're dealing with, and make sure when you're going from square feet to square inches, you're using the correct multiplier of 144. Let's go on to volume. How many cubic inches are in 1 cubic foot? Well, we just take it the same way we were a minute ago with the area. Now we're dealing with 3 dimensions, so we have length times width times height, or 1 foot times 1 foot times 1 foot equals, this is the same volume as 12 inches times 12 inches times 12 inches, right? You're following me? So here we go. If we times those all together, 12 times 12 times 12 is 1,728 cubic inches. And that is the same volume as our cubic foot. Here we have on the left 1 cubic foot. It's 1 foot by 1 foot by 1 foot. We have a comparable volume. It's the same volume. 1,728 cubic inches. It's 12 inches by 12 inches by 12 inches. Plumbers tend to make the similar mistake as we are calculating in this book. Do not make this mistake. Let's take another problem. Convert 15 cubic feet into cubic inches. Once again, in our haste, if we're not careful, we're not paying attention, be like, oh, convert cubic feet, oh, feet to inches, times it by 12. 15 times 12 is 180 cubic inches. Wrong. 15 cubic feet would need to be multiplied by 1,728 cubic inches. That would equate to 25,920 cubic inches. Again, you can see the difference, right? Please be really careful when you're converting from feet to inches, from square feet to square inches, and from cubic feet to cubic inches. Make sure you have the right multiplier and that you're paying enough attention that you won't make these mistakes. All right, follow me in your book to the section that says Symbols, Mathematics in Algebraic Form. Plumbers and other craftsmen are called upon to use formulas in project planning stages. A formula is an equation, right? But it's an equation that we can rely on to do the same thing over and over. For example, if I need to find out the volume of a cylinder, like a water heater, or the inside of a pipe, I use the same equation over and over. I don't have to figure out a new equation every time. That's a formula. Let's start out with something simple like an equation that says 10 equals 2 times 5. Basic multiplication here, right? Well, all the numbers are visible to us there, but in a formula, we replace those numbers with variables, meaning we set it up the same, but those numbers could change, and we're going to take the same action with them. Let's talk for a minute about a variable. A variable are those numbers that we can switch out within a formula. But when it comes to these equations, what you need to just kind of understand is that a variable is just a symbol. We use symbols all the time. They use down here in the text the symbol of, we put some letters together and we write the word war. I say the word war, and what happens in your mind? What are the images that come in your head? Whoa, boom! That was one little word, 3 simple letters, and all of a sudden you're like, you got all this imagery in your head. What about another word? They give the word kitten. What just happened in your mind? All of a sudden you've got images, right? This is an example of how we use letters to represent something else, and that something else is connected. Basically, these variables are going to stand as symbols. Now, there are other symbols that we have, that we use, and that we can rely on. Those symbols include our math operators. Operator being add, subtract, multiply, divide. These operators don't change. Our variables within that equation or formula, they can be interchangeable with whatever numbers. But these symbols tell us how to treat those numbers no matter what they are. And that's where it's important to understand what these operators do within an equation, right? And by now you know what to do if you see a plus sign or a subtract or divide or a multiply. And these are some of the just real basics that we will be using as we go along. Let's take a simple example of an equation that has letters in place as symbols for other numbers. And let's say we have k. In this, they give us k equals 5 and t equals 9. What we're trying to find out is, what is x? So we substitute, right? If we say, okay, k, let's put 5 in for k and let's put 9 in for t, and we'll add those together because we understand our operator, and boom, we get x equals 14. All right, so at this point, we're going to practice this for a minute. You can follow along with me with your sample problems in the book. It says each equation below, a equals 4, b equals 5, and c equals 6. We want to solve for whatever numerical answer we're trying to get as we put those together. As we start doing math this semester, please do not forget order of operations, the PEMDAS, however you wanted to remember it when you were going through grade school. But basically what this represents is, first we do parentheses, then we do exponents, then we go and multiply and divide. Finally, we do our add and subtract. Those are the priorities and the order in which we do math in equations. All right, guys, humor me here for a few minutes. I would like you to do the sample problems and some of the other review problems that we have right here in the book. I'm going to put the problem up on the screen, and then I'll give you about 10 seconds to do the problem, and then I'll provide the answer. But in the meantime, I want you to try and come up with the answer. And if you can do this without looking at your sample problems in the book, I mean, come on, let's practice. So here we go. All right, nice job, guys. That was some good practice in substituting values like numbers for the variables in different equations. If you had any trouble getting to the answer, of course, these are sample problems. It's step-by-step laid out in your book. So I'd encourage you to look through those steps and make sure you understand how we got to those answers. Let's do some more problems. These are kind of story problem format. They're the review here. There's about 4 or 5 of these, and here we go. All right, nice job, guys. Hopefully that was a good exercise for you in finding the equation in a real situation. And I want to point out that when it comes to addition and subtraction, even multiplication and division, these are math skills that we use in the trades every day. Really, we do. So it's good to be sharp on those. Another point that I would like to make here is that when it comes to math, you are welcome to use a calculator or even an app in your phone that does measurement calculations. Whatever is going to make your life easier, really, if you're using it in the field. I mean, why would you try and do math without a calculator in your daily work? It would take longer, especially if you have something like a measurements calculator that can crank it out accurately. So I welcome you to use calculators with the understanding that in the end, when you're going to take your journeyman test, you will be allowed a calculator, but only a simple scientific calculator that can do, square root functions. You will not be allowed to take your phone in with you. So as long as when you're using your phone for calculations, you also know how to do those calculations on paper or with a simpler calculator, then you should be fine. Let's have a quick look at the number line just as a reminder. You can put numbers on a straight line. You put 0 in the middle. Moving to the right are positive numbers. Moving to the left are negative numbers. And it is important that we understand the addition and subtraction of positive and negative numbers. We've done a little bit of that in these problems that we were just working on. But it's important to understand the positive and negative numbers on a line. Let's review a couple of multiplication principles. One principle being that when it comes to multiplication, it doesn't matter what order you multiply those numbers in. If it's the same numbers, you can multiply them in whichever order, you're going to get the same answer. For example, we have a series of numbers here, each of them equaling 240. Now, when we start adding positives and negatives into that multiplication, then the sign can change in the end, whether it's positive or negative. Please remember that 2 negatives will create a positive, but an odd number of negatives will maintain that negative. So we see that here's our same series of numbers. If there's one number, that's the top line, that has a negative, we keep the negative. If 2 numbers are negative, we've multiplied those together and that creates a positive, so our end result will be positive. When there's 3 negative numbers, then we end up with a negative. And if all the numbers are negative with this series of 4, then we end up with a positive number. And we see that in those series of 240. Moving on to division. Division can be written in several ways. We can put one number over the top, like 104 over 9. We can write them next to each other, and that's probably how I'm going to write it most of the time in these presentations, because it's hard for me to type in one number on top of another. Another way is for us to write the division sign or symbol in between those numbers. As we look at positive and negatives with division, it's similar to multiplication. Anytime we multiply or divide a negative by a negative, it becomes a positive. but if there's a single negative involved, we'll always keep that sign. Interesting though, when we start to go out of order with division, it significantly changes the end result. So in multiplication, it didn't seem to matter what number order we put. As long as we had those same numbers, we always get the same multiplied answer. With division, if you see here, we have 2 divided by 3 divided by 4 divided by 5, and we get 0.0333. We rearrange the order a little bit. 3 divided by 4 divided by 5 divided by 2 is 0.075. Quite different. And another example, 4 divided by 5 divided by 2 divided by 3 is 0.133. Each time we're going to get a difference, and so keep that in mind as we're dealing with division, that the order matters. Oh, and just for fun, try to say all those in a row like I did as fast as you can. I did have to cut out several of my attempts there. Let's talk about angles. Angles of degree are in reference to a circle. A circle is 360 degrees. We can divide that into portions. If we divide it in half, that's 180 degrees. We divide that in quarters, we get 90 degrees. We divide it into eighths, and we get 45 degrees, and so on. And those degrees are often what we refer to as we're dealing with fittings that change direction. So we can have a 90 bend, or it could be called a quarter bend, or a 45 degree bend or elbow. We call it an eighth bend. A lot of times we just refer to the angle like, hey, get me a 90, I need a 45. And we're just referring to those angles. The angle really is just about, we have a reference line, and then there's a difference in direction from that reference line of a certain degree. All right, so that's what we have for Unit 1 in Mathematics for Plumbers and Pipefitters. There are 13 exercise questions that I would invite you to do. You could write that on a separate piece of paper. So I would encourage you to take the time, take your quiz, and we'll see you on the next one.